Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our shockingly inquisitive viewers, Megan Sparks, 99. Great name, by the way. Thanks for the suggestion, Megan. You asked, what causes static electricity? If you've ever been zapped by a doorknob, watched your hair float like it's haunted, or pulled your laundry apart like it's trying to form alliances, today we're uncovering the invisible chaos of jumping electrons, rubbing materials, and why winter turns you into a walking science experiment, right here on Explaining Everything. Let's start with the basics. Static electricity is not some mysterious force invented by science teachers to make you fear wool sweaters. It's real, it's everywhere, and it's caused by one thing: electrons being nosy little escape artists. Everything in the universe is made up of atoms. Atoms are like tiny, invisible Lego sets with three main pieces: protons, neutrons, and electrons. Protons are the positive guys. Neutrons just chill in the middle, like Switzerland. And electrons are negatively charged and absolutely love to travel. Normally, the positives and negatives balance out and life is peaceful. But every now and then, friction happens. Something rubs against something else, and those electrons suddenly get the urge to pack their bags and move. So imagine this. You take a balloon and rub it on your head. Why? Because you're curious, or bored, or possibly 8 years old. But in doing that, you're actually creating a perfect little science experiment. When you rub the balloon against your hair, electrons jump from your hair onto the balloon. Now your hair is positively charged, and the balloon is negatively charged. This imbalance of charges causes your hair to stand up like it's auditioning for a horror movie. Each strand of hair is now pushing away from the others because they all have the same charge and don't want to be near each other. They're basically saying, "Nope, not today. Get your own space." The balloon, on the other hand, is now so full of electrons it sticks to walls because opposite charges attract. That balloon is now emotionally attached to the drywall. Now let's talk about the most infamous static electricity trap of all time: the sock and carpet combo. You've done it. Everyone's done it. You shuffle across the room like a budget ninja, and then, bam! You reach for the light switch and suddenly feel like you've been tasted by the spirit of Benjamin Franklin. Here's what's really happening. As you walk across the carpet, your socks are rubbing against it. That rubbing causes electrons to jump from the carpet fibers onto you. Suddenly, your whole body is like a walking electron warehouse. You are loaded with charge and ready to strike. Now, the doorknob, that metal thing, it's a great conductor. It's like a freeway for electrons. So the moment you touch it, all those electrons leap from you to the knob like they're late for a party. That little zap is the transfer of all that pent-up electrical energy, also known as surprise pain. But why does static electricity seem to launch a personal attack in winter? Why does it feel like the season itself is trying to hurt you? Well, winter is a dry season. The air has low humidity, which means there's not a lot of water vapor floating around. Water vapor actually helps carry extra charges away from your body. It's like nature's static mop. But in dry air, nothing's cleaning up those electrons. They stay on you, just building up until the moment you reach for your car door and it slaps you back into the Stone Age. That's why your sweaters cling, your hair floats like it's haunted, and you start looking at shopping carts with suspicion. Static electricity has a collection of classic moves, and it pulls them off with flair. One of its favorites, the laundry ambush. You take your clothes out of the dryer, and suddenly a sock is fused to your shirt. Another sock is hiding in your pants leg like it's planning an ambush. That's static at work, charging up your clothes during all that tumbling and rubbing. Another classic, the awkward zap handshake. You go in for a friendly greeting, only to deliver a shocking betrayal. That jolt can make people question their life choices. Then there's the infamous hair attack. You brush your hair, and suddenly you've got a halo of frizz surrounding your head, like you just licked a light socket. Your hair has become a rebel army, each strand standing on its own, refusing to lie flat. At the heart of all this chaos are electrons, tiny, invisible troublemakers. But not all materials treat electrons the same. Some are more generous, giving electrons away without a fuss. Others hoard them like they're collecting rare Pokémon cards. When two materials touch or rub together, one often gives up electrons, while the other gleefully accepts them. This exchange creates that imbalance we've been talking about. One object ends up positively charged, the other negatively. And once that imbalance exists, it wants to be fixed. That's why static electricity always ends with a dramatic little arc. It's the universe saying, "All right, enough imbalance, time to even this out with a tiny lightning bolt." This whole give-and-take system is based on what scientists call the triboelectric series, which is just a fancy way of saying the electron popularity chart. Materials are ranked by how likely they are to give or receive electrons. It's like high school, but for molecules. And that's what causes static electricity. Tiny imbalances between positive and negative charges, often triggered by friction, separation of materials, or even changes in humidity, leading to those unexpected little shocks or sparks. If you enjoyed this video, don't forget to like and subscribe, and hit that notification bell so you never miss out. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.